In this lesson, we are going to talk about rational exponents. From your previous grades, you learned that any number a, exponent n, is a times a times a n number of times. And n, we defined it as an integer which was either positive or negative. And we also defined that if n is negative, then this is exactly like 1 over a exponent n. Now in this lesson we are going to talk about numbers with rational exponents. The first thing that we are going to define is if the rational exponent has a numerator of 1 and a denominator n, we are going to write any number b exponent n, 1 over n, as b root n. And remember that b without exponent by default is 1. So b root n is the same as b exponent 1 over n, where b is any real number, n is a natural number greater than 0, and if n is even, then b has to be greater than or equal to 0. This is our definition of rational exponents. Now you may say, what about if the numerator of rational exponent is not equal to 1? For instance, what about if I have b exponent m over n? By using the laws of exponents, I can write this one as b exponent 1 over n times b exponent 1 over n times b exponent 1 over n times b exponent 1 over n m times. Remember that when the bases are the same, you are going to add exponents. So if I add all these together, I'm going to get b exponent 1 over n plus 1 over n plus 1 over n, which is b exponent m over n, which is exactly the same thing that we started with. But remember that b exponent 1 over n here, based on our previous notation, can be written as root n of b. So the next one here can also be written as b exponent n m times. Now when you multiply the same thing m times, this is the same as b root n exponent m, which is power of a power. So in this new definition, b exponent m divided by n is the same as root n of b exponent m, where n is a natural number, m again is an integer, and if n is even, b has to be greater than or equal to 0. Now one thing you have to remember is that all the exponent rules that you had before for powers, also they satisfy the rational exponents. For instance, any rational exponent to the power of 0 is going to give you 1. If you multiply rational exponent, if the bases are the same, you add the exponents. If you divide, you subtract the exponents, and so forth. So all those rules that you had before are going to be applied for rational exponents as well. Now let's do a couple of examples. For instance, we are supposed to find 8 exponent 1 over 3. I can write 8 as 2 exponent 3. So this becomes 2 exponent 3 exponent 1 over 3. But again, the rules for power to a power is write the same base and then multiply the exponents. 3 times 1 over 3 is going to give me 1, so the answer is 2. So this means root 3 of 8 is going to be equal to 2. The next example is negative 32 exponent 1 over 5. Negative 32, I can write it as negative 2 exponent 5, because negative 2 times negative 2 5 times is going to give me negative 32. The whole thing exponent 1 over 5. This is going to give me negative 2 exponent 5 times 1 over 5. 5 times 1 over 5 is 1, so I get negative 2 exponent 1, which is going to give me negative 2. The next example is negative 16 exponent 1 over 4. I can write this one as negative, and then 16 I can write it as 2 exponent 4 exponent 1 over 4. Remember that 2 exponent 4 is the same as 16. So this is negative 2 exponent 4 times 1 over 4, which is negative 2 exponent 1, which is negative 2. The next example is 16 over 81 exponent 1 over 4. I can write this one as 2 exponent 4, which is 16 divided by 3 exponent 4 exponent 1 over 4. Now I can distribute the power inside the bracket, so I'm going to get 2 exponent 4 times 1 over 4 divided by 3 exponent 4 times 1 over 4. 2 exponent 4 times 1 over 4 is 2 exponent 1 divided by 3 exponent 1, which is going to give me 2 over 3. The next example is negative 27 exponent negative 1 over 3. Again, by definition, I can write this one as 1 over negative 27 exponent 1 over 3. Remember, negative exponents, I can flip it and it changes the sign of the exponent, which is the same as 1 over, but negative 27 I can write it as negative, and then 3 exponent 3 exponent 1 over 3. Now this becomes, I can distribute exponent 1 over 3 to both elements, so it's going to be negative 1 exponent 1 over 3 times 3 exponent 3 times 1 over 3. Now negative 1 exponent 1 over 3 is going to give me negative 1, and 3 exponent 3 times 1 over 3 is just 3 exponent 1, so the answer is negative 1 over 3. The next example is to evaluate 8 exponent 2 over 3. 8 exponent 2 over 3, I can write 2 exponent 3, which is 8, exponent 2 over 3, which is 2 exponent 3 times 2 over 3. Now 3 times 2 over 3 is going to give me 6 over 3, which is 2, so 2 exponent 2 is going to give me 4. The next one is 81 exponent 5 over 4. 81 can be written as 3 exponent 4, the whole thing exponent 5 over 4. This is the same as 3 exponent 4 times 5 over 4, which is equal to 4 cancels with 4, so 3 exponent 5, and 3 exponent 5 is 243. The next one is 49 over 81 exponent negative 3 over 2. Because we are dealing with negative, I can just flip the base and then change the sign of the exponent. So this is the same as 81 over 49 exponent 3 over 2. Now 81 is 9 exponent 2, and 49 is 7 exponent 2 exponent 3 over 2. So if I distribute the exponent inside the bracket, I get 9 exponent 2 times 3 over 2 divided by 7 exponent 2 times 3 over 2, which is 9 exponent 2 cancels with 2, so it's going to be 9 exponent 3 divided by 7 exponent 3, which is going to be equal to 729 divided by 343. In the next example, we have to simplify the fraction and express the answers using only positive exponents. Since the bases are both of them in the numerator are x, so we can add the exponents. So we get 2 over 3 plus 2 over 3 divided by x exponent 1 over 3. 2 over 3 plus 2 over 3 gives us 4 over 3 over x exponent 1 over 3. Since we are dividing same base, we can subtract the exponents and we get x exponent. The bases are, the denominators are the same, so subtracting the numerator we get 3 over 3, which is x. The next one is y exponent 1 over 4 exponent 2 times y exponent negative 1 over 3 exponent 2. We are going to distribute the exponent 2 and exponent 2 here, so we get y exponent 2 over 4 times y exponent negative 2 over 3, which is the same as y exponent. We're just going to add the exponents. 2 over 4 minus 2 over 3, which is y exponent. Now the denominator, common denominator here is 12, so I'm going to multiply this guy by 3 and this one by 3, so I get 6 exponent 6 over 12 minus, and this one I'm going to multiply by 4 and the denominator by 4, so I get 2 times 4 is 8 over 12. So I'm going to get y exponent 6 minus 8 is negative 2 over 12. And since we have to express it only in positive exponents, I'm going to flip this one and I'm going to write it as y exponent 2 over 12, which is the same as y exponent 1 over 6. The next one is 5x exponent 1 over 2 exponent 2 times 4x exponent negative 1 over 2. I'm going to distribute this exponent inside, so I get 5 exponent 2 x exponent 1 over 2 times 2 times 4x exponent negative 1 over 2. Now 5 exponent 2 is 25. X exponent 1 over 2 times 2 cancels out, so it's going to be x times 4x exponent negative 1 over 2. Now 25 times 4 is 100, x exponent, and we can add the exponent, so 1 minus 1 over 2, so it's 100 x exponent 1 over 2. In the last example, we have the formula corresponding to a sphere with the surface area S, which is given by this formula here. It says find the volume of a spherical holding tank with a surface area of 100 square meter. So we have to find V is equal to 4 pi negative 1 over 2 divided by 3 times S is 100. But 100 can be written as 10 exponent 2, the whole thing exponent 3 over 2. Now I'm going to multiply 3 over 2 by the 10 exponent 2. I get 4 pi exponent negative over 2 times divided by 3 times 10 exponent 2 times 3 over 2 is going to simplify to 3. So I'm going to get 10 exponent 3 divided by 3 times 4 pi exponent negative 1 over 2, which when you use your calculator is going to end up to be approximately equal to 94 cubic meter.